Okay, now that you made it this far, let me show you some shortcuts to help us be a little bit easier process. So the first shortcut I want to show you is that there's an easier way to identify how many rings you need to draw for an element. And the trick is that the number of rings to draw is equal to the period number that the element is in on the periodic table. Let me show you an example. So if you're looking at your periodic table, if you didn't bring yours home, you can just Google one and find one to look at, or you can look at this one. The period number is the number on this side, so they're going across. So going across here, hydrogen and helium are in period 1, lithium, beryllium, boron to neon are in period 2, sodium starts off period 3, ending with argon. Okay, so the number of rings you're drawing is equal to the period number. So if I want to draw beryllium, I just have to look here and say that beryllium's in period 2, it's going to have 2 rings. If I want to draw barium, Ba, down in period 6, I don't have to do the math to figure it out. I know barium's going to have 6 rings. Okay, so that's a trend I would definitely record on your periodic table when you get back to school. The second shortcut I want to show you is just when it comes to drawing the Bohr model, or drawing what an atom looks like. Okay, so if I want to do sodium, this is a shortcut of how to draw it. I'm first going to draw the nucleus, and it still has to show me all the protons and neutrons. So sodium has 11 protons, and when I subtract these two, rounds to 23, 23 minus 11 is going to give me 12 neutrons. The shortcut comes with the electrons. Okay, so I know sodium has 3 rings because it's in period 3 on the periodic table. So here's my 3 rings. They're just shorter, smaller. And then all you're going to do is write how many electrons are in that ring. So the first ring would have 2 electrons. The second ring would have 8 electrons, which would leave 1 electron to go into the last ring. Okay, so 2 shortcuts you can now use. The next part of the lesson is going to be about a better representation of electrons in a model. So this is the Bohr model, which is the one you spent today drawing and you just drew some examples of. And while this is an okay starting point for you guys to visualize what goes into an atom, it's not actually what it really looks like under a really expensive machine where you could actually view the protons, neutrons, and electrons. This is called a Schrodinger model, and the Schrodinger model is much more accurate because it shows what electrons actually do. For the Bohr model, it seems like the electrons stay in place and they're not moving, as well as the neutrons and the protons. Now the neutrons and protons don't move. They move a little bit, but they still stay in the center of the atom. The electrons are moving constantly, and they move so fast and they don't stay in the same spot that the Schrodinger model is a much better representation. So while this looks like there's 1,000,000 electrons, there's not. What it's showing you is all the possible places the electron could be at any given second, since it moves so quickly. Okay, so I'm never going to ask you to draw this. It's a little ridiculous to draw, but I just want you to know that electrons are constantly moving, so this is based upon probability, whereas this isn't an actual representation of what it really looks like. To go along with that, and this is the last thing in the video, is the electron configuration. Now remember earlier today when you saw that crazy thing on the board? Looks something like this, and you had no idea what it meant? That's called electron configuration. And what it's telling us is where the electrons are. And again, knowing where the electrons are in the atom is going to become very, very important in the next few lessons, because the electrons are going to tell us a lot about what's going to happen with the element in certain situations. Okay, so basically, in just a basic overview, we're not going to go too in depth. You're not going to have to write this out for me. I just want you to know that it's showing us where the electrons are in the atom. Okay, so hydrogen, it's telling us there's 1 electron in the s orbital, and over here you can see orbitals. So s is the first one, it's the closest to the nucleus. Then you go into p orbitals, then you go into d, and lastly you'll go into f. Okay, so the more electrons you have, the more orbitals you're going to have, the more rings you're going to have, the bigger you're going to be. So what we just want to know is where the electrons are. And that's basically all it is. So you can see as you go down this list from hydrogen to helium, you're adding 1 electron. So I'm adding 1 onto my s orbital. and I'm adding an electron over here. Here this only has one electron, this one has two. And you can see as you go down here, I'm just adding electrons each and every time. So therefore I have to add more orbitals after a certain point. Like the p orbitals only hold 6, so after I add 6, now I have to go to another orbital. Okay, really, really basic. You don't ever have to explain it to me. I just want you to know that scientists really care about where the electrons are, and that's why we made this kind of language to show that. Okay. All right, go ahead and recap this whole lesson with a few more quiz questions.